So the description of this conference says that this is a JavaScript inclusive conference. So I'm going to talk about some code. Haven't heard a whole lot about code today. Today we're going to talk some code. Design patterns for modern JavaScript. So this is me. These are open source projects that I am the creator of, except for the top one. That's a company I'm a co-founder of, which is a little agency in Charlottesville. We have an overrepresentation of Charlottesvillians here today. So, yeah. This is me and my cute little family. I like to put them up there because at these tech conferences, we're just kind of all like little bubbles on Twitter or something. And there's my microphone. There's a real family behind who I am. But really, this is who I am. This is when I first started getting involved in web design. This is Internet Explorer 5 for Mac. I believe Internet Explorer 5.5 was the first browser to ship CSS support, which was really exciting. I remember coming home and saying, I need to learn this CSS thing this summer. And that's me doing that. Actual live view. But why are you here? So it's the end of the day. So if you don't know why you're here yet, I'm sorry, but this is why you should have been here. Corey House has a great quote. After attending many conferences, I've realized I don't attend to learn. I attend to learn what I need to learn. So that's kind of my goal. Is I can't possibly instill tons of JavaScript knowledge into everybody's brain today, but hopefully these start to give you clues about things that you, on your own time, are going to go home and investigate. So what are we going to learn? In this talk, we're going to learn 4 underutilized techniques and patterns. And I heard that I actually have a little bit of extra time because our happy hour doesn't open until a little bit after 4. So hopefully you guys will indulge me and be willing to listen, because this talk can go as long as we need it to go. It's all about the fundamentals. The platform. You hear a lot of people nowadays, a hot topic is use the platform. Well, what is the platform? Ultimately, it's all about the fundamentals. What are the fundamentals of the languages that we're using on a daily basis? This is just a little GIF of Steph Curry draining like 17 three-pointers in a game. And the reality is that the fundamentals are what allow somebody like that to become who they are, right? It's not the fact that he's just a master at shooting three-pointers. It's that shooting three-pointers is a fundamental of the game. And so we, as developers, need to learn about our fundamentals and what they are. And to wax poetic about this for a second, we have kind of all ended up in framework land. It almost doesn't matter who you are. You're using React, you're using Vue, you're using Svelte, you're using Angular, you're using Solid. You're using one of these libraries on a daily basis, and you're using the tools provided by those libraries to such a degree that you have largely let JavaScript pass you by. I mean, it might not be true about you, but in general, I think it's actually a pretty safe assumption. So we're gonna look into that a little bit. There's 4 things. Module scopes, we're gonna build a shopping cart. Weak map, we're gonna look at event handling. Proxies and form validation, and tag template litters and DOM templates. So these 4 concepts are highly underutilized in JavaScript. How many people use like weak maps? We got 1. All right, they're amazing, and we're gonna learn about them.
Shipped it this week.
There you go. It will be a little bit of drinking from a fire hose, so just try to stick with it. Be there with me. Module scopes. Can we use them? Yeah, we can use them. They're ready to ship pretty much everywhere. Even IE11 has some support for this. So there's no worries about is this technology too modern to actually use? You can use this. You really can. The key concept to take away: your module scope are ideal for global state. Okay? Module scopes are ideal for global state. Let's talk about this. Pop quiz. All right, I'm going to ask you guys 5 questions. In your head, take this seriously. In your head, look at the code. I'm going to show you some code on the left. You'll have 5 seconds to formulate an answer. I'm going to pop it over on the right-hand side. Okay? Here we go. All right. We've got some variables here, and then we're going to console log them down below. Just an array. Ready? Not a trick question, right? Everybody got that? Great. Okay. Number two, now we're just going to nest that inside of a function. So we still have two script tags. We've got a function that's going to return an array. And then down below, we have, we're going to call that function. We're going to push something onto that array. And then we're just going to call the function in a console log. Okay, here we go, 5 seconds. Okay, this makes sense, right? We called the function the first time. It created the array in the instance of running the function. When we call it again, it doesn't matter because it's a brand new one, right? We should all be sort of on the same page. All right, now let's get a little bit more complicated. So now we've just added type module here, and we've got our cart. And all we're going to do here is in our another type module, console log cart.
Don't do it, Carl.
All right, reference error, cart is not defined. Okay, so now we're starting to see these are the beginnings of something different going on here. Each of these modules, just by saying they're type module, has its own scope, right? So I can throw any variables I want to into each of these, and they will not pollute themselves anywhere outside of that module. Interesting. Okay, so now we've got a type module, and we're applying the values to window.cart, and then down below in a non-module, we're going to console log. Ready? 5 seconds. Okay, this is the trick question. Undefined. If you got that, I'm impressed. The only reason that this is the way it is, technically this would work, is that modules are always deferred by default. So this is really an order of operations issue. It console logged before the window.cart was ever assigned. Okay? All right, here's the last one and the most complicated. We've got an index.html function and a cart.mjs. Our cart.mjs has some apples and oranges and a function that just returns that value. And then down below, we're importing our cart, we're calling cart, pushing pair on it, and then we're console logging. Okay, so in this case, we actually modified our array. And we modified our array because the cart was defined in the module scope of that module. And by performing this cart.push down here, we were accessing the module scope of the other module and making a modification there. And then that scope was persistent, and when we called it, we got it back. So interestingly, we just created access control around a little tiny variable just by the way we structured our code. So module scope data, it does not pollute, but it allows global scope. This is a really key takeaway. It allows you to create globally scoped information without polluting all of the global space that we know we've learned we're not supposed to touch. We've learned a lot of those lessons the hard way. It persists during the entire runtime. So that pair that I pushed on there is going to be available until the page refreshes at some point. It's available, it persists. And it enables access control to your data. So let's take a look here at what this would look like to create like a little data store, something like a Vuex or a Reduxy kind of thing, just out of pure native JavaScript. No frameworks involved here. Here we've got a button. We're just going to take a look here at our fictitious store. It might be a little small. I unfortunately don't have any accessibility overlays to make that better. There's a button here. We've got data product on it, Lord of the Rings. And we want to basically make it so when you click that button, a product gets added to your cart. So we got a script type module. We got add to cart in there, and then we got some, variables sitting in a file, products.mjs. We'll leave that to your imagination, where you can get a product from by an ID. So we're going to add an event listener, just a click event listener on that there on the button. And when you click it, it gets the product and it calls add to cart from our magic cart.mjs file, which looks like this. Here we go. Here's our cart. This is familiar. This is like our apples and pears. All we're going to do is push it on. Okay. And this works. So if I click this button, you can't see anything happening, but it actually did add products to my cart. It's not very interesting though, so let's take it one step further here. We've got our little cart icon up here. Wouldn't it be nice if we could see how many items were in our cart when you click the button? Sure. So let's go ahead and we'll get that element, we get it by ID, and then after that, we're gonna just create a way to tally the total. This could look as something as simple as cart.length over there in our cart file. Now we're gonna import total, and just add a little block of text here, where we create a badge, which is a span, and we set some attribute on it, like the data total, and we append that. Okay, and then we can just render, this isn't the way I'd actually recommend doing this, but we can just render the content attributes of the data count up in there. And there it is, showing a 0 because there's nothing in our cart. Now we come over here and click, and nothing happens because we're not in a reactive framework. So we need something else to trigger when this happens. This is really, really easy to do though. These things sound complicated and they're just not. We have a handlers array in our cart, and then when something changes, when anything changes, we are going to call all of the handlers and perform an update. So here we import on change, and anytime something changes, we just set the data count attribute to be the total. Now when we're clicking on this, we actually get a number increment. If we throw some styling on there, we might actually get something that sort of looks like a shopping cart. So that's all I'm going to talk about module scopes, but I hope that what we just showed there was this idea that you can have access control around your data in a module scope very, very easily with nothing other than native JavaScript. That little QR code has like a more fleshed out version of that and a link to GitHub if you guys want to explore it on your own. I'm going to move on though. Okay, weak maps. I love weak maps. I love weak everything. I love weak maps, weak sets, maps, sets in general. They're really incredible tools that are really underutilized. And can we use them? We absolutely can use them. They have incredible support today. Here's the key concept around these. You use weak maps to attach data you own to data you don't. Okay, what do I mean by that? Well, first, we'll just knock the weak part off of this, and we'll just ask about a map. What's a map? If we have something like this, we've got two items with some x, y coordinates, some positions, and we want to associate those perhaps with some DOM elements. So I get a DOM element 1, I get DOM element 2, and then would it be nice if I could say that those coordinates belong to those elements? Well, of course, we can't actually do this, right? We can't use elements as keys of our object literals. It's not possible. But what we can do is just swap this out with a map and then add these items, and now the DOM elements are the actual keys to the data that they hold. Super, super useful. So do I own that element? I don't really own the element. There's a problem though. This right here just created a memory leak, because when I mentioned to the code that element 2 is the key, it said, oh, that's an object reference, and now I know I can't garbage collect that. So that's all that weak maps mean, is now I can store that, and since I don't own the data, the garbage collector is perfectly happy taking that element if it gets removed from the DOM, and my data gets lost and I don't care about it. But the DOM element's gone, I don't care about it, right? So that's good. You use weak maps to attach data you own to data you don't. And what in this case here, I've got a variable. I own that variable, I created that variable, I instantiated that variable. In the case of document get element by ID, I don't own that DOM element. I have access to it, but I don't own it. Okay? And so in that case, if I want to attach information to that DOM element, well, there's a bunch of hacky ways I can do that. I can like put some attributes on it, or I can do something like that. But this is a far, far better way that doesn't lead to any memory leaks. So attach data to objects you don't own. It's memory safe. And a key takeaway here is that it enables idempotent functions. Are we all familiar with idempotency? It's a scary word. It's not really scary. Basically, you can ask yourself, does performing this action multiple times change the result? If the answer is no, then something is idempotent. If every time you call a counter to increment, it increments, that's not an idempotent function. Okay? So here's a little example. Add color. I'm adding colors to this array. If every time I add it, I'm adding another item, that right there would be considered non-idempotent, where at the bottom, if I'm adding the color and every single time it's essentially deduping and making sure that there's only one red in the list, that would be idempotent. So how does this allow that? Well, Vue, which I'm very familiar with, actually uses this heavily. Weak maps are heavily used for idempotency in the actual reactivity core. So for example, when you call reactive on an object in Vue, it gives you back a proxy of that object, which we're going to talk about in a second. But value A and my object are not equivalent right here. When I call it again on the same object, it actually returns the exact same variable, the exact same data. It only did the computation once, and it did that because it stored the result of the first computation in a weak map. It said, oh, I know that data you gave me. I already did a computation for it. Let me just hand this right back to you. So you can call reactive on the same object 100 times and have absolutely no computation take place. So an example would be something like a click handler. If I have a document.addEventListener click, this is not really an idempotent function, right? If I add 5 click handlers, I'm going to have 5 console logs at the end of the day. So this would be an example of how, in just, 5, 6 lines of code, you could create an idempotent event handler. So export on click, target would be a DOM element, and the listener would be a callback. And then we just have a weak map that's sitting in the module scope, right? And so that's a global scope. So anytime somebody gives me that DOM element, I just go and look up, is there already a click handler for this? And if there is, don't do anything, but replace the callback. That's all that's happening here. There's a weak map, and inside of here, we just, when the click actually happens, we go get the click handler from that weak map in module scope, and we call it. And that means I can bind as many times this on click, and whatever the last one to be called is the value of the click handler. So here, one of the open source libraries I maintain is something called AutoAnimate, which if you guys haven't heard of it, it's a single function. You can stick it on anything that's mutating DOM elements, and it automatically adds, sweet little transitions like that. It's unbelievably easy to use. But this is all based on weak maps and weak sets, because we can know the information about the DOM elements that are actually in there. If you haven't checked it out, you should check it out. It works in literally every single Angular, React, Solid, Vue, Svelte, everything. Proxies. Proxies enable magic. Have you guys used proxies? Anybody? Okay. We got the weak map guy doing the proxies too, so that's good. Yeah, proxies enable magic, and I know what you're all thinking. Magic, isn't it bad? No, magic's not bad. Too much magic is bad. Magic is good. Magic can be good. It's not always good, but it can be very good. Can we use these? We can absolutely use these, unless you need IE11 support. This is why a lot of really recent frameworks have dropped support for IE11, is because they want to use proxies. Okay, so what is a proxy? Well, here I've got an object literal target with location earth, and then a proxy is a native feature of JavaScript where I just pass my object literal as the first argument. That's called the target. And then it gives me back some data, and I can console log that data location, and why. And this GIF's already been used today. Why does that matter? Well, why it matters is really what's going on right here. This tiny little object allows you to specify what should happen when data.location is accessed. So I could have passed this object in there. In this case, I have a getter and a setter, and now I have a getter and a setter for just my arbitrary properties of my object. There's a lot more things. There's a ton of other things that you can do, although getters and setters are usually the most common of these. So how does this work? Here I've got a slightly more complicated example, but it's still relatively simple. I still have my target location earth, but now I've added just one thing here. I've added a getter. And when you call it, there's this special built-in JavaScript called reflect, and you can say reflect.get, reflect.set. That just does whatever was going to happen. Okay, you just take the arguments from the getter and you pass it to the reflect, and it performs the operation. So in this case, it's actually getting data.location from my object. So now the val there has my location. And in this case, I'm prepending an emoji. So now, when I add console log data.location, I don't just get back Earth, I get back an emoji and Earth together. So the key concept around proxies are like middleware for your objects. It basically lets you step directly in front of any access requests to objects and do something. All right. I know some of you are over your head, but we're going to go a little bit deeper here. Here's a common use case. This is probably the most used feature right now of proxies, although some people have come up with some other pretty neat things. It's basically tracking dependencies. So if you guys are tuned in at all to the Twitter tech world, you've heard a lot about signals and things like that. I mean, just today we were listening to talk about it quick. Signals are great, and a lot of them under the hood use proxies, some of them don't. Vue uses proxies exclusively to track dependencies for fine-grained reactivity. So if, let's say you have a callback where you're doing something and it has like an early return, well then none of the other things that the function should do should ever cause that function to rerun unless the primary thing that was blocking that function from running is resolved. So here is a really simple, this is as simple as I can possibly make it for how somebody can track dependencies. In our case here, we've got something called form data. This could just be form information that you're getting off of a web form. And you're putting it up into this object literal up top there. Now, we have a set, which is like an array version of a map. And whenever a property is accessed, so like our data.location, which previously was returning Earth, we just add that property to our set up here. Drag.add property. And then right before we run the user's function, we clear everything out. It's like a scene. We run the function, and then we see, so here in our function, data.foobar got accessed. And so when the function's done running, we say, okay, what got touched in that function? And in this case, the only thing that got touched was foobar. So now we know not to run some user function again unless foobar changes. And we know when foobar changes because we have a proxy on it. So I'm going to brave a little bit of a live demo here, see how this goes. Okay, the implementation is right down here. It looks complicated. It's actually not that complicated, but it does look complicated. But fundamentally what's happening is over on this left-hand side here, I have some inputs with some names. And every time somebody types into our form here, every time somebody types in over here, we are updating a proxy called form data, just like in our previous example. Okay? And now I want to put some validation functions on here. So here's a validation function for email. We're just making sure if we return true, it's passing. If we return a string, then that's a failing validation rule. This isn't actually how I recommend doing validation, by the way, but it's a good example. So as I type in here, you can see that my validation rule automatically resolves. And it's resolving because formdata.email got changed. And so we're recalling our required rule again. And that rule is then resolving true or false. Okay, but what if we wanted to have another rule? So let's just create something like a password confirmation. So I'm going to get my form data, and remember that's the proxy. And then I'm going to say if my form data's password is equal to form data password confirm, return true. Otherwise, return something like passwords don't match. Okay, and then I'll just add it to the rules that need to get run. And for good measure, I'm going to throw a console log in here so you can see ran confirm. So if you think about it, if you look through this function, the proxy is going to see form data.password, and it's going to see form data password confirm. That's what's actually going to be seen. And so those will become the dependencies. So the first time it runs, you can see that's just the first, it should run one time there. The first time it runs, it's going to detect that these two things are basically the same because they're both empty. And so it'll say, yeah, that's passing. But as soon as I type a character in here, it's going to run my confirmation rule again and say, now these two things are no longer passing. Now, what if I type up here? No console log. Okay. Now, I didn't tell the code anywhere other than in my confirmation rule that the email address was not part of it. My form data is getting updated, but that rule is never being run again. And it's never being run again because it knows that only formdata.password and formdata.passwordconfirm are used in that rule. And so now we have basically fine-grained reactivity on a validation rule, which is kind of neat. So if I say hi, and I say hi, my rules resolve. All right. That's proxies. They're everywhere. They're incredibly valuable. You can use them for all kinds of cool things. The last thing I want to talk about is tag template literals. So what are template literals? You guys know this one, right? Everybody knows this. We got a console log here of hello location. This is basic string interpolation. If you were writing JavaScript before template literals, you know what a godsend they are. And can we use them? Yes, we can absolutely use them with the same IE11 caveat. So what are tagged template literals? Tagged template literals are essentially the same thing except for this little string of characters right on the front side. When you do that, this is just part of JavaScript syntax that's not as well known. It actually converts this into essentially a function call. So emojify, in this case, is a function that will get called. There's nothing special about this function. This is just a plain old JavaScript function. It will get called with my string and then any expressions those are the interpolated areas automatically. So in this case, I'm just injecting an emoji right before the second piece. So now when I do a console log, instead of getting that, I get an emoji. The key concept here is tag template literals are like middleware for strings. So proxies are like middleware for objects. Tag template literals are like middleware for strings. So here's the API. You just write a function. Any plain old function will do. The first argument is an array of the string portions. So in this case, the array of strings there is a string space, comma, space, and then space. And then you get the expression. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. How could we use this? Well, we could write something that does a fancy console log. Here we just are logging something. Instead of actually typing console log, we just use a function or a tag template literal log. All this is going to do is concatenate the strings and the expressions back together again, which is kind of the default behavior of a template literal, and console log it. But then we have an effect in here. And the effect is we're going to post that back to our API. So anytime a console log is happening on the front end, we're also posting something back to our back end somewhere. So a use case for this might be to create DOM elements. If you guys have written very much native JavaScript, you know that this is the API that we're given. It's incredibly implicit. It's rather boring, quite arduous to work with. But with something as simple as this, we could actually resolve that entire problem. So here's just a function. It takes a string that looks and smells a lot like HTML. And I've called my function DOM. And all DOM does is create a new DOM parser, which is nothing particularly fancy. This is just another native API. And it just passes the string into there, and it returns DOM nodes. So now I could have DOM, some H1 information. I could put as much HTML as I want in there, and it's going to actually return the DOM nodes back to me. I can go append those to the body or do whatever I want with them, all in just 5 lines of code. And I can reuse that anywhere I want to in my application. It's a pretty powerful concept. If you look right here, this strings is going to be anything that's in my base strings, and we're just going to pass it to the DOM parser, get elements back, and append them to the body. Is anybody familiar with lit HTML? All right, weak map guy again. Awesome. Lit HTML is really cool. It basically uses these to allow you to create like a sort of framework. right, where you say like HTML on the front side, and then it gives you back, you don't have to give a string back. Like you saw, we gave DOM elements back. In this case, they're giving back a function, and then you're calling that function with some state, something that you want to do inside of that function. And you basically get you know, like a reactive-ish kind of framework. You just have to remember to call those functions over and over again. So here's my say hi, and then I'm passing in you know, a string that I want to have interpolated, and it works. It renders different DOM nodes. But what if we combine all 4 of these techniques? What would be possible? And that is what's possible. A land of unicorns, rainbows. Here's some combined concepts. I had a crazy idea one night, so I started working on this. I created 2 functions, R and T. R is a proxy object, T is a template object. You could just, you know, create something like this, location earth. This looks familiar. And then I could just input inside of there my HTML markup, just like we saw with the tag template literal. And now my expression is just a function that is accessing the reactive value. Okay? And the return value is something that I can just mount to the document. And if I change the location, it automatically changes, it just reactively updates my DOM automatically. This is not using React or Svelte or Vue. None of these are involved. This is just pure native JavaScript like we just walked through. It's using weak maps, it's using proxies, it's using tag template literals. So what if a component could look just like this? What if a component was literally just a function? No crazy use state stuff and it being recalled 42 times, nothing like that. What if a store could look like this? So here's a little gift. I'm releasing this crazy idea as open source. It's 2 kilobytes. There's no virtual DOM. It has fine-grained reactivity. It's declarative rendering. There's absolutely no build tool, no compilers, nothing. And everything that you learn about how to use a tool like this is transferable because you're just learning native JavaScript. You're not learning any fancy framework tooling. It's called ArrowJS, and here's some links to it, and I'll show you some demos. So here's the documentation for it. You can see here's a really basic example of creating something reactive. You get your click firing. There's a total of 3 functions in this entire library. R, W, and T, or HTML. T would be HTML, R would be reactive, W would be watch. I'll go down here to the bottom, and I just want to, like, the question that everybody wants to know right away is, oh, well, is this performant or not? So I have this little demo here. Here we've got 500 cells being updated in Vue on a 10 millisecond debounce. And they're just putting random values in there. And it's pretty fast, but it can't keep up. This is Arrow doing the same thing. And it's really fast. And it's really fast because there's no virtual DOM. It does not need to crawl down into the virtual DOM to parse. It's fine-grained reactivity at the point of use, so not that dissimilar from Quick or Solid, but there's no compile step required to get to that point. I'm going to jump over here to CodePen. And I'll just jump into one of these for fun. Here's playing around with memoized values. So one of the great things is you can literally use this anywhere. Here I'm just importing it from a URL. Which is something that ES6 modules support natively. I'm just importing my functions. I'm creating some width, length, height, and that's it. Here I've got my HTML. I'm rendering a table, and then anywhere I want a reactive value, I just put an expression and access my state, and that's it. I get a fully reactive interface with ridiculous performance and a 2 kilobyte size. I mean, it's so small because it's so native, right? There's very little that the actual library is shipping. You can create really standard looking applications out of it. This would be, something you would create with any other kind of app. Here's a carousel, drop downs. These are all these are components with local state code reuse. So each of these is just a component being used multiple times with different props being passed to it. And a component is literally just a function that returns values. Tabs. There's a lot more to do on the docs here. This is obviously experimental. It's at the top of the docs. But it is really, really neat. So that is Arrow, and it is basically just a culmination of everything we talked about today. So hopefully you guys can take some of these techniques. And my goal with all of this, including this library, is basically to try to get JavaScript developers to sort of break out of their bounds and realize that the JavaScript landscape is actually quite rich and fertile, and we don't always need all of the compilers and build tools and everything else. Not saying that they're wrong, we just don't always need them. They're not always necessary. And a 2 kilobyte penalty, you can put this inside of a React app without feeling guilty about it. It's like a rounding error for React. All right, so that's me. There's my Twitter. These are some of the other projects I work on if you want to look them up. And that's it. Any questions? Yeah?
Should your tracker be a week set?
Should it be a week set? It should be a week set. Yes. Good question. Yeah?
So the last thing you said about putting ArrowJS into React, are there, what kind of implications or gotchas would there be with putting that into React?
You don't want, so React is unhappy if the nodes that it's rendering are being modified by somebody else. So you wouldn't want Arrow to be responsible for touching any of the nodes or any of the DOM elements that React is also touching. But let's say you had a carousel component, and that was the inner body of a React component, that would be completely fine. Yeah. Okay. All right, thanks everybody.